So, hi, thanks for joining my talk. The guy before me, he told the story of moving from ops to dev and back again. So, I will try to tell you my story of moving a little bit to the architecture role and what does it take for me to be an architect. Several years ago, I joined the company as a software engineering role. And I was doing an engineering job. So then I passed a solution architecture course, and I started to do an architecture work. Like the last year, I was in a role of, I did some architecture work, and I also did some team leading and implementation, so I'm not doing architecture work all the time. And I decided to make a talk about it, so what I thought of it when I was a developer, and how I see it after practicing it officially after 1 year. So my name is Konstantin Slisenko. I came from Belarus, Minsk. I'm working in EPAM. And in Belarus, we have a Java community. It's called Java Professionals BY. And both from EPAM and from Java community, Belarus Java community, we have gifts. I will give you a gift, so you can see some souvenirs here. There are caps, there are some toys, t-shirts and bags. I will give you a gift for the good question. So we have about 13 gifts here, so we can nominate 13 questions. So let's agree on the rule that if you are giving me a good question or a good comment, and if I say good question, that you can take any of that. Just one, but one item per person, please. Okay, so 13 gifts, it's not very hard to win something, just be active. Also, first of all, want to talk that this is based on my own experience. And the role of architect, the people who call in them as an architect, could be very different depending on the company. So the responsibilities are very blurred. So if in your company the architects are doing different things, that's totally okay. So I will share what I saw in my practice. And as I'm working in a big company, and the customers are in a big company, so it's not a startup environment. So that's my talk will be focused more on how we do in architecture in the big enterprises. And as we are a big company, so we have teams in different cities and the time zones. That's why we have communication issues all the time. We have to spend a lot and focus a lot on the proper communication and documentation. We have enough time and money. That means we can follow the right process. We can spend time doing the documentation, working on requirements. So it's also completely not about the startup environment. So how to do an architecture in a startup, that's a completely different topic. Let's start a little bit from the beginning. So what actually is architecture? So here I found some blueprint. So by the way, this is the reference architecture. So this is the blueprint of the system that follows so it can solve some business problem. We can use it for solving some business problem. And this is the architecture. But there were a lot of work that was done before we came to particular this design. So we'll start from the very beginning, just a long time before that. And from my point of view, the architecture starts from business. So you should understand business, you should understand your business domain. You cannot design a payment system or a trading system if you do not understand the business. Then we're working a lot with the stakeholders. We identify requirements and constraints. Then we're making design decisions. This is, by the way, when I was a developer, I thought of architects that they're mostly busy with design decisions. We're documenting and communicating a lot. So if you're not familiar with several words here, like what is a stakeholder, what is the constraint, no problem. So we'll cover that in today's talk. Do you know that, guys? Who doesn't know who are that guys? Please raise your hand. Just a couple of people. Everybody know. Okay, let's imagine that Master Yoda and Anakin Skywalker are working for IT company. So Yoda is a very experienced architect, 10 plus years experience. He was working in multiple companies at the chief architect positions, so he's wise. And he never tells you how exactly you should do. He just giving, like Yoda, he just giving you right direction. And Anakin is also smart. So he's a passionate developer. He always follows the best practices of the industry, like TDD, pair programming, extreme programming, ridiculous programming. He's visiting conferences and meetups, especially he visiting Devoxx Kyiv all the time to know the latest trends in the industry. So he likes to try the best technology. And he wished to be an architect. He is already, by the way, already thinking that he can be an architect. And they're working in the company that is called Traders.inc. By the way, this company never exists. So, but let's imagine that there is a company, and their business is the software for traders. So you have money, you can buy stocks, you can sell stocks. And they provide in some services, so you can buy premium account with having some fancy additional features that will be definitely useful for you as a trader. And they may also charge commissions from every time you buy and sell in something. So this is their business. And this is how their software looks like. So they can have a kind of a microservice architecture. And definitely you should have the client applications. We have an API gateway. And we have several microservices, like everything related to trading. It's always about some orders, some money transactions. We have a chart. Chart is something that you want to see the historical price of the stock for the last, for example, 2 years. So how the Apple stock was doing. So this is chart. So you can see this chart on a page to see what you want to buy the stock and sell the stock. And they have a strategy tools. So strategy tool is some smart algorithm inside the service that suggests the traders the best optimal strategy. So that's a key feature that helps you to make more money. All these services need data. So they have a data layer that is a layer of abstraction. I'm talking about the stock pricing data. So what is the price of the stock, the historical pricing, the current pricing. And in order to get the data, they have a partnership company that gathers the data from multiple stock exchanges, and they're storing it in the database in the aggregated form. So data layer go into the database, and all the services go into the data layer. This is, by the way, how it works. And one day businesses come in saying that, hey, by the way, this is a very competitive market. So there are a lot of trading platforms, and they're saying that competitors, they have a lot of features. And if we don't catch up with competitors, so we'll be out of business in 1 year. That's sad. So we need to reduce the cost, we need to catch up the competitors, and we need to attract more users to the platform. This is, by the way, how business is talking. So, and then there is the Anakin's time to shine. So he came in saying that we can help you by rewriting everything, refactor it. We can use the latest reactive programming, Kubernetes, cloud, everything, and we'll be good. But they say no. So you're not just do whatever you're doing. And that's really sad. It happened to me many times. So when I want to refactor something, to do it properly, but they say no, just we have some other job for you. And when he came to Yoda, by the way, he told him that the thing is, you don't understand how business makes money. So whatever you're proposing doesn't make sense, so they don't listen to you. And if you poorly understand the business goals, then you're making the wrong design decisions. And then it leads to the software that doesn't make money, so it's wrong software, and it leads the business to fail. So let's talk a little bit about the business goals, why it's important for us to understand the business goals first. Shortly speaking, we can fit anything that's happening in the company into 2 categories. So either we're reducing cost or increasing revenue. For example, any technology decision we can link with a business, like the Graal VM. So why Twitter is using Graal VM? Because for their use case, they can tune the Graal VM that gives them performance boost. So they can use less hardware and save millions of dollars per year. And when we're talking to business, they're saying, hey, first of all, there is the provider that gives us the data. They are too expensive for us. And luckily, not only us, not only we have a competitors, but the data providers also have competitors. So we found another company that provides us the same data, but for a much better price. And they don't require us to maintain a database. So we can just call an API and do not use a database and the integration mechanism. By the way, in my last project, we did that. And when we changed the database to API, so we no longer need a database, and it was an Oracle database. So, and just the license cost for the company was $100,000 per year, but you need to always also hire a database engineer, you need to buy the hardware, so database is very expensive. And we can attract more users because the strategy tools, there is a very smart algorithm that suggests you how to trade. Then when we started the business, we were pioneers, so that was a key feature. But now everyone has it. And by the way, there are companies that provide this strategy algorithm as a service, and they have 100 other algorithms. And it's really expensive to implement that because we need to pay a lot of money to the smart business analysts who know that trading algorithms. It's really hard to test it. So how do you test that your algorithm suggests you the right strategies? That's not a trivial question. So we would better find another company that provides this as a service and just integrate it and no longer do development of it. So this is how the software looks. These are the components that cost more money for us. And first of all, we eliminate the need of this expensive provider and the database. And as a second, we remove in the strategy tools and provide an integration with other company. So this is how business goals impact architecture, not because we are rewriting to a new cool framework. So we're about to start coding after we made such design decision, but we need to do something else. So does anyone have any ideas? Before we start coding, what else we need to do? Yeah, please. Choose technologies. Okay, what else? Requirements. Good question. Good comment. That's for you. Yeah, but even before requirements, we need to make stakeholders. So who are the stakeholders? Why we cannot start coding without stakeholders? So we're looking at the business as something solid. So we see the company. There is always a single opinion of how the company makes money, of how they're doing the projects. But it's completely wrong. So there are many people in there. So some of them are operations. There are development team. There are product managers, sponsors, infrastructure guys. If we are a financial business, we definitely should have security architect. So many of them, they may have different concerns. And business doesn't not exist in vacuum. So you should also consider, for example, government regulators. Especially if we're a financial business, we are regulated. If we're in a gambling, like casino business, it's really complex. It's really different in the countries. So that we should know about it. And we have our partners, we have users. So all of them are stakeholders. Stakeholders are people that are responsible for different requirement areas. They are maybe not as technical, but they impact on design decisions. So we're starting talking to stakeholders, and as you said that we need to come up with identifying requirements and the constraints. But stakeholders, they don't really give us the requirements. They're sharing their concerns. For example, and just before we start talking to stakeholders, just a small note. It sounds really obvious, so there is nothing special here, that smart architect communicate to different stakeholders differently. It really sounds obvious, but I will show you the typical mistake that the beginner architect doing usually when communicating especially his design decisions. So we're talking to product manager. So she's saying that this basically was her idea, where she knows the market, she knows what are the other companies that providing the data, providing the strategy tools. And she's saying that after we switch to the new data provider, the user experience should not decrease. So that means performance should remain the same or better, and the uptime. But she doesn't tell you the numbers. I mean, the response time, what's going to be response time. The product managers, they don't know about it. I didn't see it. We go into infrastructure team. They have this pretty fancy data center because we are on premises. We are financial. We don't trust any cloud providers. But the progress makes sense. So they planning sometimes go to the cloud. But they saying we're going into the Q3 2020. It's too long time to wait. And right now we have to go on premises, so we cannot still use cloud. We're talking to the web and mobile developers. There are client applications, so they're saying, hey, we have a lot of stories in the backlog, and we understand your project is important, but we have no time to change anything. So we need to somehow plan that server side, we make changes on the server side, but the client side, we don't have to do any change. So we need to build some backward compatible API to what was it before. So we talk to stakeholders, and it doesn't happen just once. Sometimes they come back to us given the new concerns. So this is our role to be like a communication person. And we started identifying requirements. When I'm talking about requirements, I'm usually mean that non-functional requirements. So functional requirements are more about product managers, business analysts. But business analysts, I didn't see when they give you some performance number requirements or what's going to be the uptime. How do you make a failover? So this is the architect role to track it. So remember the product manager, she wanted us to, just the user experience does not decrease. So, but she didn't give the numbers. We come into the log files. We analyze the log files for the last half a year. We go into the monitoring system and found out that 95% of the API calls, took less than 3 seconds, and we have 1,000 concurrent users. So let's put it as a requirement. This is like a baseline. When we implement the new service, make performance testing, we can compare against this baseline. The uptime should not decrease. By the way, there is a good practice of measuring uptime. So we have a monitoring system that's saying like we are 99.9, but especially in my company, I didn't see that someone really cares about it. Just that should work. At least we can formulate it as no single point of failure. At least we can check this requirement. So that means we should deploy in multiple instances, multiple data centers, redundant connections, load balancers, that kind of stuff. And from the client teams, we've got that we have to build a backward compatible API. So we built a new service, but it should talk the same API. So they don't have to do any changes. And we can only deploy in premises. So number one, number two, we call it requirements. It's how the system should work. But three and number four, there is a term called constraint. Constraint is something that has 0 degree of freedom. So the API must be backward compatible. We have nothing to do against it. It doesn't make sense to decide whether we use JSON or gRPC or GraphQL. So just whatever we have, we need to do the same. The same as for deployment. Constraints is something that we're living in the world of constraints. So constraint is always time and budget. There are team skills. So if we have the team that familiar with Java, they have a Java development, and we have a limited time, and like we need to rewrite something in 3 months, it's not probably the good time to try Kotlin because it's like takes some time for us. It may be good if we have more time for it. So we have to do it in Java. Also, many companies has a kind of approved technology stack. There was a talk about it yesterday. So there is a list of frameworks that you can only use that frameworks or that technologies. For example, in our case, we can use Java, Spring Boot, and Node.js, but there is no, like, Python is not approved technology stack. That happens because we don't want the zoo of technologies to grow to complex maintenance. So this is also the constraints. And it never happens that whenever you start the project, you know everything in the beginning. So there are some things that you are not familiar. There are assumptions. So we are saying that, but we have to start from doing some design, even if you don't have the full set of information. So we need to document assumptions accordingly. For example, if we want to achieve the response time 3 seconds, then we assume that SLA of the data provider, it should match that requirement. So their response time should be like 2 seconds, at least less than 3 seconds. By the way, who doesn't know what the SLA is? Could you raise your hand? Okay, so SLA is a service level agreement. For example, when we using some API that provided by other company, we want to define that, okay, response time should be 2 seconds or not greater than 2 seconds for 95% of the calls, like for 1,000 concurrent users, and the maximum downtime should be not more than 2 hours per month. And if you want to do any maintenance, you can do it only on the weekends. So this is what we put in the contract when we sign the contract with them. And if you go to any cloud provider like AWS, they have an SLA for any of the AWS service written. So this is like agreement between companies. And Also, if we don't want to have any single point of failure, that we can deploy everything in the multiple instances, multiple data centers, redundant infrastructure. But if the provider, they provide us just a one IP address and the network fails, then we are failed. So they should provide us more than one endpoint, better in a multiple data centers in a different geographic location. But we don't know that yet. So we haven't signed the contract with the provider company, the new provider company. So we'll put it as an assumption. When I'm working with requirements, I usually categorizing them in this way. I will suggest you a book that has a good catalog of different categories, different requirements. So you can just open it and match to your project. Say, okay, did I cover performance requirements, security, availability? We'll not stop on that much. So after we figured out the requirement, we did that job, then it's time to make an architecture design. Maybe that's the most interesting work that architect is doing. I will tell a little bit about the toolbox that architect can use, but we will not probably cover a lot of how to do some complex application design, because today we're more talking about the role and what are the process, what are the steps. So you can use different styles. Like every style, it has the use case, it has advantages, disadvantages. There is always a trade-off, so you should match it to your requirements. And pattern is something more granular, like there are integration patterns, fault tolerance patterns. By the way, this is plenty of information available in many conferences, many books, so this is everyone talking about it, so it's not any secret. And also a good tool that architect may use are reference architectures. So this is the blueprint of some system or some problem that was already solved, and you can get that reference architectures somewhere on the internet. You can adapt it to your case. This is what you can use. So just before we come into design, make sure that whenever you make a design decisions, at least you can explain how it can achieve any business goal in the requirement. Just not because we're using something, not because it's cool or popular. And it's always be ready for criticizing, to be criticized a lot. There is no ideal architecture. Everything is always debatable point. So I believe there are 100 ways of doing something, and maybe a couple of them will be really good. So let's check how do we link the design decision to requirements. First one is very obvious. So we're deploying on premises because the cloud migration in the company is not yet completed. Then for the performance requirements, let's use some kind of caching. Let's use distributed cache because we have uptime requirements. I mean, no single point of failure, so we have multiple instances, and they may share the distributed cache. Let's deploy multiple instances in the multiple data centers. Let's have disaster recovery data center. If the data provider has a second failover endpoint, like another IP address, let's implement a circuit breaker, so it automatically switches into failover connection. And yeah, if we have to make a backward compatible API, so we check, we use JSON, so we need to use the same data format. So this is how we do linking design decisions to requirements. Then it's time to communicate. So the role of architect is in between of dev team, infrastructure team, security engineers, other stakeholders, maybe some top management. And we should always pass what we learned. So if you are not communicating, that means nobody is going to implement it. So this is the diagrams. We usually communicate in the form of the diagrams. So this is the diagram that I can provide it. So if you look at it, do you really understand what you want to say? Who understands that? Me too. Because understanding of that is pain. I mean, I saw a lot of diagrams like that. In my company, we have a diagram that if you print it, it would be like this size. And it has a lot of small components, so it shows how the whole company works. I'm calling it Adventures of Indiana Jones, because you can start from one point and eventually you can come to any place in the company. And this is how usually people look like, especially business guys, when you propose in your technical decisions, how they're looking at your diagrams. So let's come back a little bit. The typical mistake here is a mixing of layers of abstraction. So there was an attempt to show both infrastructure and both some Java components on the same place. So that's why it's mixing up. And here we came back to the slide that's saying that we should communicate with different stakeholders differently. Just why we actually doing this diagramming stuff? Because we need to explain something to someone. So we have the group of people, the target audience, and we need the goal. For example, we need to explain the high-level plan for the whole project to the business guys. So they don't need the technical details. They don't need the way, how do we deploy it, how do we secure it. They just need the high-level information. So there are multiple point of views on the architecture. Like business guys, what they're thinking, how developers see the architecture, how the infrastructure guys, how security guys. And for different stakeholders, we may create a different even set of diagrams. We can create a different architecture documents. For example, for business guys, we may do a context view. For developers, we may say that the architecture is a set of components. So there are services, protocols, they interact to each other, and we document that. For the infrastructure guys, they consider our Java application as just a one jar file that they put on the server and run it. So they're more interested in how do we deploy in the multiple data centers, how do we do fault tolerance. So they need another kind of views. And depending on your needs, you may create other views, especially like if you have some data flow, you may have a data flow view on some, I don't know, anything else. So this is an example of the context view. At least you can start from that kind of diagram. So what do we have here? We have three core components, like we have trading, charts, strategy tools, we have the vendors, we have the client applications. This is what we're showing to product managers, to business people, when we want to just agree that, okay, we are going with that providers, we're going with that module. So this is how it works on the high level. This is an example of the component view. So when you want to explain your design to the engineering team, you're saying, okay, this is the component. There are the protocols. There are the other systems. It has some modules inside. So you communicate your design. Just what's important here is the legend. So I saw many diagrams when there were like arrows of different color or different shapes, and nobody guessed what it is. So if you're making a legend, you like discipline yourself. So the dashed arrow is a HTTP call, and the straight arrow is something like a Java dependency. So you should only use all the like shapes from that legend. And this is the example of deployment view. So we have multiple data centers for redundancy. We have some load balancers. We have API gateway. We have, I don't know, cross-connect to the other data centers. We have a DNS here. This is how do you communicate your design to the infrastructure guys. So I also prefer to do an architecture decision log. For example, we have a discussion whether we want to go with Kafka or we go with a peer-to-peer. We had a long discussion. We found the pros and cons of each solution. Then we decided, okay, Kafka is not for that good use case. So let's just document and somewhere put to the decision log. Because after a couple of months, someone comes to me and says, hey, why are you still not using Kafka? I'm saying, oh, I don't remember. We discussed something, but then I can point him to the decision log. Hey, we made a design decision. So just look at that. Also, it can like formalize your communication to the stakeholders. For example, we had a situation when, so in the company, we are deploying the different infrastructure per channel. So for mobile app, we have a different set of servers. For web, we have a different set of servers. Just for the additional, so the load on web doesn't impact mobile. So this is the approach. But when we started one of the projects, the management, they wanted like to reduce the cost a little bit. Say, okay, let's share the infrastructure. So I say, okay, let me put it to the decision log. I say, no, because nobody wants to get fired in case something goes wrong. So then we got a fully functional set of servers for an environment. And you can also enhance it, like make a responsible person column and use it as a tool. When it comes to the documentation, that's actually the thing that the architects are producing. So when we are doing the coding, when we are developing, we making a pull request. So we are writing code. And the architect, what he's doing an architecture documentation. This is the product of his work. And I really didn't see a good documentation anywhere when I was working. I don't know why. When we are looking to the construction industry, they have the blueprints of the building with all the sizing. But in a software, nobody really cares about documentation. So I don't know. There is always a lot of excuses, especially we have no time for the documentation. But we always have the time to gather a long meetings, invite 20 people in it, and ask it, many people, does anybody knows about it? No, that Vasya knew about it, but he already left the company, so nobody knows that. And there is always enough time for it. So I see the two actual purposes of why the documentation is useful. Everyone has a Confluence, right? Or any other wiki. We have a Confluence. So we can use it for knowledge sharing. We can put anything here. But the part that more architect is playing his role is the design review documentation. So how it works in my case. When we start a new project, I'm gathering requirements, I'm working with stakeholders, I'm making some design decisions, then I'm creating different diagrams. I compose in a design document when I put all that. And as we are changing the existing architecture, so we may add some new services, we may remove some existing services. Here I'm documenting how the system is changed from state A to state B, and what are the new components, how do we switch between all the new versions, what is the rollback plan, what are the alternatives, so anything. Then the infrastructure engineer, they come into play, they're documenting infrastructure details, they're estimating the cost of infrastructure, how much money does it take to buy a new servers, for example. Then I submit this document to the architecture review committee. So in the company, we have like two levels of architecture. The one is just a tech lead or like guys like me who doing mixing development and architecture work. And another one is a chief architect and an architecture committee. So they have a security engineer, they have an infrastructure engineer, like there is a team. And several times a week they gather and you can submit your design document for the review. So there is a review session. They are looking at your design, they're making comments, and they're like different stakeholders validate your architecture from their point of view. For example, security architect, they have a lot of guidelines in the company, like a checklist, what you need requirements, with a lot of security requirements. So they just giving you that information. And this is a document we don't really update it. So we just made a design document for the change that we are going to do. We got it approved, then we start in development. Then we should probably contribute it to the knowledge base. This is how it works for us. And it depends on your needs, what the architecture document usually have. There are the things that I usually put. There are business goals, stakeholders, requirements, constraints, all that stuff. So we were talking about lots of stuff that I can say that there is related to the architect role. It's not just a one-time process because business is always moving. So business always have something new. And we're starting always from some new business goals. We're working with stakeholders. We are identifying requirements, constraints. Based on that requirements, we're making design decisions. We're producing the documents. We're passing the architecture reviews. Then we start an implementation. And again, just what I want to say here that not any business goals and user stories, they really impact on architecture. So if we already have like a web application, the API database, if we want just to add the new feature, there is no job for architect. Just add new controller, data, some couple of tables in the database, and you'll be fine. And there is always a pressure from business, but there is a back pressure from the architecture. For example, the business may come up with idea, but we can say that this, if we want to implement it, having the current architecture that we have, that may cost a lot, really a lot. So it doesn't make much sense. So there is always a back pressure. Or we should say that if we don't fix the technical debt, then we'll have the system completely hard to maintain it in a half a year. And just we learned several things. I hope you learned something new. What's next? So how do you can go ahead after having that information? I suggest that books. So take a moment and take a picture. We have some time. I can a little bit explain what you can start with. So this one is a good book from start to start. It's Simon Brown, Software Architecture for Developers. So it's quite an easy way to tell if you are in a developer background to a little bit tell you what an architecture. This one, the one in the middle, software designing software architectures. It has something similar that I told you. It takes several projects from very beginning when we are gathering requirements and shows how do we link requirements to design decisions. Unfortunately, I found that the examples in that book a little bit outdated. So with like 10 years old applications in the way they're doing it, but still the idea is important. So they showing how do you go from requirements to design decisions, how do you communicate it. This one is about a lot of fault tolerance patterns on how do we deploy something in production, how do we make sure that it breaks so we can easily troubleshoot it. The software systems architecture in the middle top is the good catalog of different requirements like performance, availability, scalability, so you can just get it and take a subset that is useful for your project. And designing data-intensive applications is just a good book for it's saying how the systems like Hadoop, Cassandra, the relational databases are working. It's more technical. Okay. Also, how do you go proceed? If you are still not doing an architecture design, but you want to start, just start doing an architecture documentation for your existing project. Try to understand all the requirements. Try to understand design decisions. Make a decision log. Try to understand how the system is deployed. Make a deployment diagram. And if you have a tech lead or an architect, I'm sure he will see that, and then he will be more open to engage you in that activities. There is no magic. There are just tools that we're using every time. Especially, I'm using draw.io and Confluence for my work. And yep, please, there is a right time to ask the questions. Thank you. Yeah, by the way, for the good questions, we still have 12 gifts. Yep.
Do you use any architectural frameworks?
Which kind of framework do you mean?
I mean, there are some.
Sorry?
There are some architectural frameworks. Do you use any of them?
I've heard of architecture framework that called TOGAF. I never got into that. I think that the framework, I already talked about the framework, that stakeholders requirement. This is basically the framework that I'm using for doing the architecture. Do you mean frameworks in terms of development or?
No, like set of some practices you should follow when doing your design.
Those are my practices. Just you're doing the design in the company that already has a lot of guidelines. We have it. So for example, for security, we have a Confluence space that's saying everything that needs to be implemented for security. Yeah, we're definitely using it. But the framework is basically about preparing the design documentation, submitting to review. There is a committee. This is how the architecture works in the company. Maybe I didn't get your question right.
No. I got it. Okay, thanks.
Yeah.
Hi. Yeah. Hi. Sometimes during the design phase, we receive questions from senior leadership on what will be the cost of introduction of new technology into our stack. So what will be your advice on how to calculate those costs, or maybe to redirect those questions? Thank you.
Okay, good question. So I never had a question about exact cost. Just accept the infrastructure. So infrastructure you may calculate. Like we need 10 new servers, each server costs that money. So this is the infrastructure engineer is usually in charge of it. For the cost of design decision, I would say that I wouldn't say exact cost. You can never measure it. Like you need to prove that if we do some design decision, for example, we have a better maintenance, or we can add new features really more simple than, or if we make some quick and dirty, then it takes more time for it. And it's usually more like what are the pros and the cons of each design decision, rather than some exact numbers. So I don't think that it's possible to come up with two exact numbers. Yep. Okay. Yep.
Thank you for your talk. It was really interesting. And my question is, sometimes we have customers who are technology aware and they have some preferences regarding some technologies. And that could be people from not architecture staff. It could be business people. So how do you succeed to convince them not to use their favorite technologies when they are not applicable, for example. So how do you deal with this stuff? Thanks.
So the question is about some non-technical guys that forcing you to use the particular technology. Okay, this is in my case. Okay, so if they're not using event sourcing, just how to convince. I think the right way to go from their concerns like performance or the scale, saying you have like 10,000 requests per second. That means if you do not, this is the way you can implement it. For example, using event sourcing. Otherwise, you need to, I don't know, buy a very expensive hardware that can just use just a regular database, and that will cost you much. So I think for the non-technical people, you need to correlate to money, to cost. That's the way to go. Yeah, good question. Okay, here.
Okay, hi. All the books that was presented in the presentation was said that system architecture or software architecture or data architecture, and it stated that you are a solution architect. What do you mean by that? Why not software, any other kind?
Yeah, good question. Thanks. So we have 3 good questions, right? I'm really not good at counting it here. So yeah, a lot of roles, and even system architect role can be completely different depending on the company. So I had a lot of different discussions with other guys that call them architects. So solution architect is the guy in the middle between like business and like an engineering team. So he knows the business domain very well. For example, we can call solution architect in a trading or in a payment. And if we are talking about like system architect, or that may be the guy who just doing infrastructure architecture. So he knows that routers and machines, so how to make redundant load balancers, but he may not be aware at all on the business domain. So this is more like infrastructure space. I've heard some of the companies, they may have the architect that doesn't really deal in about business. So he's saying like, give me all requirements and I will make a design for you. But I don't really believe that that works. So if you don't know business, you may not make very wise decisions. I saw the role of like chief architect or enterprise architect. In my case, this is the guy who just head of that committee that all the tech leads bring their design documents, and his job is mainly reviewing that design documents. So he's responsible for approving or not approving. He's building a strategy of which technologies will be used in the company, for example, in the next like 5 years. So he's responsible for that, like if we're going to the cloud or not. So, and the reason why this committee should be, because otherwise the like teams, tech leads, everyone can do the completely different things. So they need to make sure that he needs to give a feedback to the tech leads or the local teams, make sure that all of that they're doing is aligned with the global like policy of the company. This is also what I saw in my life. The architects in consulting companies, they may be more engaged into like a client engagement. So they may just visit clients and prepare some consulting proposals, work on the pre-sale stuff. So there are people that called architect also. So it's really different. It's dependent on the company's business.
Thank you.
Yep.
Hey, over here. You said that architecture is kind of set of trade-offs when you decide on the designs. Do you gather any feedback from the dev team or maybe retrospective of architectures implemented afterwards? Like how do you like measure that? Whether it was good architecture or not and optimal? Okay,
a good question. I'm not as far from development team right now, so I prefer to stay hands-on. In my case, I'm more doing architecture work in the beginning of the project, and then I'm also engaged in, I'm doing some coding as well. So I get this feedback really quick. So I'm like one of that teams. And I think that maybe in that part of my career, I still want to be hands-on because I develop some project, make a system design, deploy it in production, and they support a little bit to see what was working, what was not. So that's very important. I don't think that the architect who just making a designs and doesn't participate in implementation, he may be too far away from the reality. But I don't know other way rather than staying hands-on of how to deal with it.
Great. Thank you.
Yep.
Thanks. First, thanks for the great presentation. It's really useful. I have a question. You mentioned the flow when you create design, send the design to approval, like commit it to the wiki, then share with the team, and so on. But things is changing. So it's not only architecture at the beginning and then we are writing. Usually, in some phases, it changes, or even you can lose control and someone start to do something else. So how you deal with this situation in your procedures?
Okay, how the architecture dealing with changes, right? Change.
Yep, and in your infrastructure, because it's
Okay,
different.
in my case, it's more looks like a waterfall-like approach. So when we start a new project that requires kind of a significant architecture change, that we have to pass this architecture review, so we got approval and we need to stick to that. But not all the business changes really require us, for example, to create a new microservices or new instances of them, new integrations. So some of them just adding new features to existing services. So this is not, I don't see, it's just you can create a task and any engineer can work on it. For the changes, if we are talking about kind of a environment when we are in an agile, when we have a 2-week sprints, I would say that that loop should be much faster. I'm talking of this one. So that should we do every sprint or something like that. Or maybe we should do something that will be developed in the next 2 sprints, for example. So we are bringing it to grooming like a technical product owner. That happens to me because initially we passed architecture review, but some of the requirements that we need to figure out on the fly. So yeah, for example, if I get some new, I can just reach to security. In terms of security, I can reach to security guy anyway and confirm on that some requirements. So it's more about reaching maybe specific stakeholders directly and getting a written confirmation that this is the way we can do. But the big design we're doing in the beginning.
Okay, thanks a lot.
Yep.
Hi. Let's imagine I'm a solution architecture, right? And I'm taking some decisions, of course, with my teams and other teams and so on. And how to recognize that the decision is correct for now or it's wrong until it's not too late.
I will come back to...
Even if I understand business requirements correct on my own opinion.
I will come back to this slide. So you will never know. I mean, it's always the decisions that you do. You may always have another opinions how to do that. Just in my case, get a list of pros and cons and like try to look at it from the point of view of what makes sense for the current requirements, what are the trade-offs that we are taking. Some of the decisions I may not able to take such responsibility. I may defer it to chief architect, for example, saying, hey, we have 2 options of doing that. So what do you like to choose? But usually if you are thinking of it as a set of pros and cons, if you are taking it from the requirement, you pretty much get into the best decision in most of the cases. Also, maintain decision logs. So if you are writing down your decisions, then you just formalize it for yourself as well, so you understand it much better. But of course, and again, before you deploy it in production, before you really run it, for me, there is only the one way to validate it properly.
Thanks.
Yep. Yeah, good question. Thank you.
Hello. Do you still write a code? If no, how do you feel? If yes, what is the percentage?
Yes, I do. So I'm maybe 20% of my work I'm writing the code. In the beginning of the project, I'm doing the project skeletons. I'm doing some POCs if we need to validate something. So it depends. if there is a task that other engineers can do, if I can precisely define acceptance criteria, I would better focus on something else. This is my role. But nobody like telling me, should I write the code or not? So my goal to deliver the project in production and make sure that all requirements are implemented in a time and budget. So I'm personally doing that, yeah. Because we don't have a big project, there is not a big team. Yep.
Thank you.
Hi, I'm there. Thank you for your talk. My question is mostly more about these debates. Do you have some maybe techniques or how to call it to avoid subjective decisions? So if one person responsible for decision, the decision usually is subjective. Are there any techniques to avoid it?
The techniques to make decision less subjective, right? Is that the question?
To make it more objective, yeah.
Yes, of course. This is all about that. So you have the, okay, just remember this slide, right? And see this slide. So when I'm doing architecture document, I have like this kind of table when I put different requirements, and I put some design decisions just near to the requirements. So why, for example, for that performance that we use cache or we use something else. This is the technique that can make my decisions more objective. Just linking that in a written form with the requirements, design decisions.
Thanks.
Yep, good question.
Hello. Do you have some advices how to intercommunicate with stakeholders about long-term long-term solutions which are not valuable for business now but can have pretty benefit on the out? It's like for technical debt which can need be done or refactoring some stuff. It's not valuable for a business for now.
So,
but it can bring.
This is the question because some of the stakeholders, especially, okay, you need to convince your stakeholders on some solution, right? So you're saying that this would be benefit in the long term, but that depends on the stakeholder. So for example, if we are talking with product managers, then maybe they just have a set of user stories for us right now, so we design based on that. And I can ask, hey guys, what are your long-term plans? So we can fit the current user stories into something bigger. Usually there is a big problem. Just if you see that, okay, if we implement something small now, then it wouldn't be okay for us in the future. So then you're coming to other stakeholder. It's the project sponsor and manager that's responsible for the budget and for the time of delivery. And engaging this stakeholder, you may, and the product managers, then you need to agree on they need to agree on the trade-off. So either we invest in upfront in some better extendable architecture, or we're doing something small but release it now. And I don't think that as an architect, you may have your opinion, but your opinion should be, for the business, if it's better to deliver something really quick, then for me, it doesn't make sense to propose something, build something strong and big upfront, because business may just want to try something new. If it doesn't work, then throw it away. So
but
that's why it
will grow and it will be problem in half year. It will be growth and it will be problem in half year.
Sorry, could you say it again?
So if we start from some small, we try it, then business asks, okay, let's add something more, and in half year it will be big, not nice.
Well, but if you're talking about a really agile environment, you never know how the product will look in the next year, because all the time they're experimenting. And this is more about architecture in startups. So I had one friend, he's a CTO of a startup. So when he saw my presentation, he told that you are talking about big enterprise. We're not doing that. Architecture in our case is more like incident management. So having something that already crashed in production, he has this information to convince the business that we need to invest in the more fault tolerance or refactor something right now. So that something already broke. This works in his way. And then he said that we're working in the startup, so we have a budget for another 2 or 3 months, and rather than we're building something upfront, we better add a couple of more features than have a new customer, so we can then have money for another couple of months. This is how it works in the startup.
Thanks.
Yeah.
Okay, thank you. And whatever you told to us today was ended with production release, right? So we create some architecture, we follow how it is implemented, we consider some integrations for run it in production, but if you deliver some core functionality, then release to production just the beginning of your journey, because all the integrations are incoming. How can you architect this?
I mean, if we design some core functionality and we release it first time?
It can be replacement for some existing service. It can be some new killer feature for your company or else. And all the rest, 100 teams should integrate with you.
Oh, we have exactly the same problem right now. First of all, we are doing a soft launch. So we implement the service and we deploy it in production and nobody currently connects to it. So that's the first stage number 1. Then we have the other teams. We discuss with each team what will be the comfortable way for them to switch to the new service. Some of the teams, they may implement the feature controller, so they have that functionality. For example, mobile guys, they may have a feature controller already in place. So we can agree that we can do a feature controller, we can switch only like internal users, that employees of the company as a beta testers or specific users to it. Otherwise, if, for example, other team, the web team, they don't have a feature, don't want to spend time on the feature control, then we engage an infrastructure team to saying, okay, on the load balancer, could you switch 5% of the sessions to the new service, for example? Then we do in kind of a canary releasing. This is the way.
Well, okay, thank you, but the question, well, a little bit differ. Let's say you design REST API, and you state that your service would communicate via REST API, but 10 teams out of 100 say, we don't use REST API, we need Kafka. We are event-driven, and so your architecture doesn't fit their needs.
Well, in our case, sometimes you have to enforce them, saying, for example, we were rewriting the old solution that was, actually it was like a desktop application. So the financial companies, they still may use desktop applications. And it was using like a direct TCP IP connections. So, and we say, okay, now we'll do only on a WebSocket. You have no other way to do. So then they had to integrate with it, because we cannot, if we start supporting all that different types of messaging formats and the integration approaches, that doesn't bring our product the value. So because it will be too hard to maintenance, right? So other teams, they may want to have still the RESTful API that may also fit in the strategy. So sometimes you need to enforce, sometimes you need to like build something backward compatible. So from the old version, when they switch to the new version, they have no changes. Some of the decisions are not really technical. It's up to the manager. So manager can convince other teams, or he may say that, okay, we would better not touch these guys. And if he cannot convince other team, he may go to like a CIO and they will figure that out. So my job is more say, okay, we have different approaches. That approach has that advantages and disadvantages, other has that. And this is now, please make like political decision.
Okay, thank you.
Yeah, good question.
I have another question. What do you think, who's responsible for developing good development processes in the team, good development culture in the team? So for example, is it your responsibility as an architect to introduce continuous integration, delivery, code reviews, code coverage, check style tools, and so on? So what do you think about that?
It depends on the company size. If it's a small company, then there could be one guy. In our case, this is done by other team. It's usually called development productivity teams in the companies. So they develop tool set. They're responsible of the sonar, continuous integration, that kind of stuff. I think the architect is more about requirements, design, that kind of thing. And then you given the design to the team and they start implementing. So like, I think it's separate from development practices. But the architecture is also the process. So the fact that we have this committee, that we have architecture review, by the way, we have a template for the design document. You need to fill in different sections on it. This is also the process, and this is the role of chief architect to define the architecture process in the company. And do we have the time for more questions? No? Okay, thank you very much. Reach to me in person. Yep, bye-bye.